Hello everyone, and thanks for joining our webinar today. I'm Oliver Wang with Moxa, and I'll be moderating today's webinar on the top 5 tips to extend your industrial Ethernet connections. If you have any questions at any time during the session, use the questions pane on your screen to submit your question. We'll have a Q&A session after the presentation to address as many questions as we can. Let us know if there are any challenges you are facing that are not covered in today's session. We definitely want to hear about those. Today's presenters are Paul Wacker, manager of Moxa's Edge Connectivity team, and Ariana Drivdahl with the Industrial Ethernet Infrastructure team. Paul has many years of experience working with top-tier manufacturers to improve their operational flexibility and efficiency through networking and communications, and has been a guest speaker at many industry events. Ariana has a background in programming and engineering and has spent the past 10 years helping implement communication installations in transportation, factory automation, aerospace, and other industries. I'll hand it over to Paul to get us started.
Hey, thanks, Oliver, and thanks to those of you joining us today. Let's go ahead and get this started, and I think you'll find, at least a useful tip or two for all of you joining us. I really like this topic since we get to cover, practical applications of some really interesting technology on this one. So let's go ahead and move on here. And let me just jump right in and start off. I think the best place to start this is just with a brief review of Ethernet. It's been just kind of fascinating where it's come in such a short amount of time. And if we could just kind of take a brief look here, you'll kind of find a lot of changes through the life cycle of Ethernet. Starting from a real simple technology that was, really came to popularity in the early 80s through Xerox and Bob Metcalf deploying that. And looking back, it's kind of funny that it was only 3 megabits as its first approach the marketplace, and then jumped to 10 megabits per second, with the real first commercial push with that. And the thing that really catapulted it into popularity is the ability of moving past the former coaxial cable type of connections and go to twisted pair, which most of you are familiar with today, right? Whether it's Cat5 cable that you might use at your desktop or within a control panel on that. The most exciting thing is really that the technology's been able to advance almost at the rate of which we've seen microprocessors advance by, every number of years being able to kind of jump by an order of magnitude. So, where a lot of us are using a 100 megabits per Ethernet, a gigabit is come down in price and become very flexible, actually, kind of real important for a number of applications. And there's 100 gigabits being deployed in commercial installations in the data center. So it's just a matter of time before that technology will trickle down to the edge of the network for that. So maybe for a good starting point here is a little icebreaker for us this morning, or for today. Let's take a quick poll, Oliver, and I'd like to throw this question out for those of you folks. And I know we've got folks of different experience levels here, and this really kind of sets the scope of the conversation for today. What's the maximum distance of Ethernet over Cat5 cable? And it's not a trick question, it's a really simple one. Is it 50 feet, 100 feet, 328 feet, or 500 feet? If you could, kind of interact with us there and click on the checkbox for the poll. We'd love to get your feedback. And we'll give it just a few more moments here.
All right, we're going to close the polls in just a second, and we'll take a look and see how all of you guys did. All right, let's take a look.
So now that we know the baseline of that, now we can look at some of the other technologies here as well. So this is just a little summary. In that Cat5 cable, it was not a trick here. You'll find that whether you're running 100 megabit Ethernet or even gigabit, it's still the same limitation, about 328 feet or 100 meters for that. Now, we already know the limitation of Ethernet in terms of distance, but there's some other things to consider as you kind of look at today's topic. One of those is the inherent nature of carrying signals over a copper cable, electrical signals. By sheer nature of it, copper cable is susceptible to electromagnetic interference. So, any of you folks working in an environment with machine shops with different types of electrical equipment, whether they be motor starters, contactors, even things like maintenance equipment for doing arc welding on a piece of equipment, all of those things can cause, communications faults with your equipment anytime you're switching a large load. Likewise, another common problem when you're working with copper cabling is ground faults, and this is simply differences in the ground potential among different pieces of equipment. This can even be different amongst, a span of one AC outlet to another, or it can be a span on a piece of equipment, or even worse when you look at things for going inter-building types of connections. And it can be actually life-threatening. Some of you who've maybe been a little experienced have maybe found that you need to be careful when you're plugging in test equipment or even plugging in a laptop. I know in a past life as an applications engineer, a common thing was if you weren't careful, you'd take out the ports on your laptop if you weren't careful, and that's just simply that the current's trying to find a quick path to ground with which to do that. And lastly, there can be certain situations where you can have a catastrophic event that might be something like lightning, in terms of a building a remote application. So let's take a look at the first tip on here. On this first tip, let's talk about utilizing a switch with which to do that. And this is a real simple one, and sometimes it's so simple a lot of people forget. The concept here is that you plug into a switch, and out of the switch, extend that in a linear fashion. So we have, 300 feet on one side, you can now take that and make that be, almost 650 feet on that. And you can be able to do this to actually have multiple switches and do these in a, if you would say, daisy chain or cascading fashion to extend those connections even further. Now, how does that work? Well, it actually kind of plays upon the basic operation of a switch. Remember, the switch is going to accept those signals from the attached devices and run those through the magnetic isolation that's built into an Ethernet PHY, and sharpen up all the signals and square them up, and basically work as a repeater. So that switch is able to repeat the signal, and what comes out of the switch is all cleaned up and ready to go another 328 feet for that one. Now, switches do add a little bit of latency. It varies from switch to switch and from manufacturer to manufacturer, but it's really minor. We're talking in a realm of a few microseconds. So you can put 3 or 4 switches in series and not really see any appreciable distance in terms of latency for that. Okay, so there's one of the techniques with utilizing a switch. Let's move on to number 2, and this one's a little bit of an old school trick, and it's actually something we do in some of the training sessions we do here at Moxa as a quick way to be able to utilize a twisted pair of copper to extend signals. And we're going to give you a couple of those tricks to use different types of media. And this one works on utilizing point-to-point protocol. And some of you may have never heard this, some of you may have forgotten about it. It was actually one of the more common protocols utilized for dial-up internet. I don't know, I can't remember that far back. It seems like forever ago. Back when you had to use a dial-up modem and you used that to go over your phone cables. What was used there is in order to give you an internet connection over that modem connection, we used PPP protocol. And it's still in use today for certain types of applications, and some of the foundations of this technology have been built upon to do VPN-style type connections. So, for example, when you're traveling outside of the office, some of the foundations of this were the building blocks to give you VPN technology. And basically, it's a protocol for connecting point-to-point connections, typically between 2 computers, and it goes over a serial connection. Generally, when you're doing this, you're going to be limiting your speeds to under 1 megabit per second. And for light duty applications, this works out really nicely. In essence, it gives you an IP connection at both ends of the link, That means you can run multiple things over the same communications path, multiple protocols. So for example, you might be monitoring Modbus to one device and maybe using proprietary or specific technology to go to a device, or maybe use a web interface on port 80 for that, all at the same time over that connection for that. Now, the way you do this, and we'll show you how to apply that, is by utilizing a device server. Some of you may be aware of this technology, utilizing a little small box about the size of a deck of playing cards that actually has an embedded processor in there with a real-time operating system, as well as all of the application software to support this. And this is going to basically take the place of where you might have used a full computer in the past for that, and put these into a configuration that looks like the following. And the following would look something like this. So they're kind of used in a basically a point-to-point link like this. The configuration is where you're going to have basically the Ethernet exposed to the attached devices, and then use the serial link in between on this. The serial link is going to, be wired in a couple different fashions. Normally, you'd like to go full duplex on this, meaning that you can transmit and receive at the same time. So you would probably use RS-422 for 4 wires. You could use RS-485 and run that in half duplex, but you'd only be able to send or receive, not simultaneously for that. So a little bit about it. This really kind of requires upon the right type of application where you've got, a copper cable installed, the speed's not tremendously high. Maybe you've got a real limited budget to utilize a real low-cost solution like this with which to do that. Let's go to the next one here, and let me just change something here. Bear with me just for a second. And let's go to our third tip on here, to be able to use a fiber media converter. And it looks like maybe my slide is not coming up there. I'm not quite sure why we're having a problem. There we go. So let's use a fiber media converter. And before we do, some of you may not be familiar with fiber media converters. Let's talk a little about what this consists of. So basically, we're talking about being able to take our Ethernet connection and be able to convert that copper signal to fiber optic signals. So this is utilizing light pulses instead of electrical signals on the copper cable. And some of you folks may know a little about this. Basically, we're using the ability to shine that light down a small piece of glass fiber and be able to have that bounce to carry that across that path. So basically, it is being internally reflected through that. You could probably do a whole little mini seminar on some of the capabilities of this, but for the gist of it, we're basically utilizing that technology. In the architecture standpoint of this, it looks something like the following, and this is the nice part is, provided that you can attach fiber amongst those connections, it's a real simple architecture. So on the left-hand side, we're going to have our incoming Ethernet connection coming in on the left. So you connect via Ethernet and utilize the first media converter here to convert to optical fiber, and then on the opposite end, we're going to kind of bring that back. The great part about this is it actually works at the physical layer. So it will work with multiple technologies, including Ethernet, and it's really agnostic to the IP layer, which is great to have a transparent like that. The other part I wanted to point out here is that it does require 2 fiber optic connections, and oftentimes you'll find these in a duplex type of cable, particularly at the ends of your network, where you have one fiber used for transmit, and then you have a separate fiber used for receive coming back like this. There are other ways to do this, but this is by far the most commonplace way to do that with a duplex fiber cable, where transmit in one direction, receive in the other for this. In terms of distances, you can get quite far distances. Let's talk a little about some more of the technology on the fiber end of things. So here's where we get to another point about utilizing fiber media converters. We want to make sure that, when you do this, that you have to utilize the same fiber type of technology on both ends of your link. So for example, if you're going to do 100 megabit fiber, you've got to have 100 megabit fiber and a 100 megabit a transceiver or receiver at the other end of it. You can't mix and match 100 megabit gigabit like you can with a copper Ethernet connections on here. And this is just a kind of little snapshot of some of the common different types of fiber specifications. Generally, it gets a little more complex with gigabit that you find here in kind of the lower half of this slide, where you're basically finding differences that range on the types of distances that you want to go. And what's happening here is you're finding that there are different types of light sources and photodetectors that give you the longer ranges. And as you can expect here, the further you go, it tends to be a more specialized, utilizing laser type optics, and typically being more expensive for that type of technology for that. You'll find two different types of ways of doing this. In the previous slide we looked at here, you kind of saw built-in fiber capabilities. That again is utilizing just the built-in fiber transceiver here. There is another technology that's kind of interesting that I want to talk about. Let's kind of work up towards that. So as a summary, you've got both the fiber type is important in doing your selection criteria for this. So there's two fundamental types, one being multi-mode, one being single mode. Multi-mode being the more common, and typically for longer distances you're going to find single mode being more useful on that. That's kind of characterized by the construction of the fiber, and you'll see that here in terms of when you do select the fiber, they'll rate this by the core, which is the inner diameter on here, and then the cladding, which is the outer diameter on here. And so you'll see the differences here. That's important in the selection process. And I wouldn't get too concerned about this, since most folks will be bringing in a specialist to do this type of thing, since you do need to terminate cables, where it's maybe a little more pertinent probably to most of you joining us today is in choosing patch cables at the edge of your network. And then lastly, the connector type. This is where it gets a little complex, and particularly in choosing the type of media converter you want to use, you need to match the terminations of the fiber to the terminations of what you do. And you'll find that you've got a couple different types here, from the ST type, which is a twist type connector, to the SC, which is a clicked, as you push it, it clicks into place. If you're utilizing technology I'll talk about in the next slide, you'll find an LC type connector. And sometimes the guys in the data center like the MTRJ types of connectors here. Let's move on to one more thing that's important here, and I wanted to introduce the concept of the small form factorable pluggable module, or the SFP. And this is really one of the great technologies that came out of the data center and allowed us to be able to have a modular architecture to this. So the little module you see up in the upper right-hand corner is about the size of a AA battery. It's a hot swappable or hot pluggable type technology where you can actually remove and replace under power. And it does utilize the LC type connector, again important when you're looking at this, to be able to understand what to do. And it really gives you the best of both worlds in terms of giving you flexibility. So you can choose single mode or multi-mode by the fiber that you choose, module that you choose, and be able to pick speeds as well as the operating temperature that you want for that. Okay, great. So kind of in finishing up this section, here's a little bit just more about the media converter. I think it's a great technology. I think Ariana's going to give us a little bit of a summary at the end to kind of compare and contrast a couple of these technologies. And with that, I'd like to go ahead and turn it over to Ariana here for the next tip about another technology.
All right, thanks everybody, and thanks Paul for that awesome first half of the webinar. As Paul mentioned, I'm going to go ahead and finish up the last part of the webinar here with two more tricks. One is if you already have existing wires that you want to continue to use, and one is if you don't have any wires at all. So I'm going to talk a little bit about DSL extenders, and then finally I'm going to finish up with some wireless. So our tip number 4 is, again, using a DSL extender. So, we have a lot of circumstances, and particularly in some vertical markets, where there already is existing copper wiring, whether that be a phone line, whether that be a DSL line, or sometimes even just plain, 20-gauge copper wire. And a lot of times we have an Ethernet network that basically dead ends, or we want to extend into that type of wiring. You know, one of the nice new technologies that has come up in the last few years is called a DSL extender. And essentially what this does is it can extend an Ethernet network over just any kind of two-wire copper. So, you know, again, whether that be a twisted pair, whether that just be literally two 26-gauge or thicker wires, you can basically extend Ethernet above just about anything. And that's really nice because it's a huge, huge cost savings, especially when you already have those kinds of wiring built into your infrastructure and you don't want to have to spend the money to basically trench new fiber or new Ethernet cable. The nice thing about DSL extenders as well is that they're extremely flexible in terms of what you can do to your topology and how far out from your main control center or your main, you know, control room you can basically extend them. You know, there's two main types of Ethernet extenders on the market. One is kind of a standalone Ethernet extender, and then one is one that has Ethernet ports built into it. And the standalone DSL extenders typically are just you know, they take in Ethernet on one side and they put out across DSL on the other side. And so they're useful for kind of like a onesie-twosie run off of kind of a main control area. The nice thing about some of the newer devices that we see in the market is that they include managed switches. So now you're able to build very long-distance redundant rings or redundant chains. You know, you can daisy chain with them out to, you know, kilometers away from where your Ethernet network originated. And it's just a great way, again, to reuse existing cabling to save money to be able to bring your Ethernet network to a very, very long distance that it didn't have before. Now, when we talk about DSL extenders, there's basically two main standards that are available on the market today, and whatever your bandwidth and distance requirements are will kind of dictate which one of the two you look at. But the two predominant ones are SHDSL and VDSL2. SHDSL is the farther of the two technologies. It'll allow you to go upwards of about 8 kilometers in terms of extending the network, but the caveat is that the data rate is going to be significantly lower, so typically around 192 kilobits per second. If you need a little bit of a higher bandwidth, for example around a meg, then VDSL2 is going to be the one that you're going to want to take a look at. You do sacrifice a little bit of that distance, so that one can only go up to about 3 kilometers, but again the data rate is much higher. So if you have any kind of video or other little bit more bandwidth intensive applications that you want to bring that are very remote, you definitely want to probably take a look at the VDSL standard. Now, these are just some pictures that we took of, you know, people who were trenching and trying to put in new cable or new fiber. So, you know, obviously not everybody has the budget for this, or not everybody has the will to do this kind of installation, because you're talking about bringing up concrete or, you know, putting in temporary wires, and they're not really the best scenarios. So if you have a situation where you need to do one of these things in order to extend your network, a DSL extender might be something that you want to take a look at. Now again, you know, you can use just about any copper cable. Ideally, a twisted pair is going to work best, but we literally have just taken two single 26-gauge wires and plugged one end into a DSL extender and plugged the other end into another DSL extender, and it still worked very, very well. So the amazing thing about this technology is that, you know, you can use just about any wire. Obviously, the worse condition the wire is in, the less bandwidth you're going to get, but it's pretty incredible. We've actually even tested using a coat hanger, if you can believe it, and we're still able to get communication across it. So the technology is pretty unbelievable, and again is really great for people who don't want to have to pull any kind of a new fiber or new cable within their facility. All right, so I'd like to ask you guys, have any of you seen a need for this type of technology? And if so, you know, where have you seen it in? In transportation, factory automation, oil and gas, other, or I just haven't really seen a need for them. You know, we here at Moxa have definitely seen some industries that a little bit are a little bit more prevalent or have a little bit more of a need for this than others. I'm just kind of curious to see if you guys have seen the same type of scenario. So we're going to give you guys just a little bit more time here.
So for some of you who are answering other, if you wouldn't mind, in the questions pane indicating where else have you seen the need for DSL extenders, we'd be very curious to see if it's outside these three industries. So we'll go ahead and close the poll soon, and we'll see how everyone responded.
All right, thanks, Oliver. So it looks like factory automation, transportation, oil and gas are pretty darn close to each other, but it looks like quite a few of you actually haven't seen a need for DSL extenders. So some very interesting results there. And again, as Oliver mentioned, for those of you who put other, if you wouldn't mind just letting us know what industries that is, we would certainly appreciate it. All right, so to give you guys some examples of where we've seen this, one of the most predominant markets for us actually is intelligent transportation, or ITS. And what we've done is we've seen a lot of people who have cabinets or traffic cabinets that are far away from an existing perhaps redundant ring or control center. And we've had people who have wanted to bring things like traffic light signaling or video monitoring back into an existing network without having to retrench for other wiring. So this is a really great scenario, or a great example of where this type of technology can be used. This is a little bit more of a complex view of that type of application. This one is actually going to be in a harbor as opposed to ITS, but essentially in this application example, we had somebody who was trying to bring several points along a harbor route back into a control center, and they had a difficulty because a lot of these were several kilometers away. They really didn't have the option to do any kind of cabling, and they needed to have kind of some advanced functionality, and so a DSL extender really was ideal for them. And I wanted to put this up because harbor communication isn't one that's a very typical application, but these devices, while maybe more common in things like ITS, really are useful in almost any industry out there, just pretty much anywhere where people want to extend an Ethernet network but don't have the ability to pull any kind of cabling. And that brings us to our last tip here, which is setting up a wireless link. So since we're kind of on a time frame here, I'm going to focus most of the time on Wi-Fi because that is actually the most common wireless communication medium and the one that we've seen used most frequently. So one of the main things to note about Wi-Fi is that there are 4 main standards that are being used today. I did not include 802.11ac in this just because it's not as in wide use as some of the older ones are, even though it's beginning to be that way in our industry. But the 4 common ones are 802.11a, b, g, and n. And 802.11a and b were ratified back in 1999. I know that was a long, long time ago. For those of you who remember how to party like it's 1999, that's when those were ratified. And they were both created to address kind of different needs. So 802.11b was created to have a little bit of a longer distance need, whereas 802.11a was created to have more of a high speed but shorter distance need. So 802.11a operates on 5 gigahertz frequencies, and 802.11b operates on 2.4 gigahertz frequencies. So there's kind of an inverse relationship in wireless between frequency and distance. So the lower the frequency, the longer the distance, the wireless communication will travel. And that's why when you see things like 900 megahertz systems, those can travel upwards of 10, 20, 30, 40, even 50 kilometers away. It's because they do have that lower frequency associated with them. Now those two work great for a while, but people started wanting to combine both. They said, hey, we want long distance and we want high bandwidth. IEEE, what can you do? And so they created 802.11g, and that is a standard that runs off of 2.4 gigahertz, just like 802.11b, but operates at that higher 54 megabit, just like 802.11a does. Now for many, many, many years, that was okay, and eventually people started wanting to do more over wireless. So when it first started out, it was, hey, I want to send an email, I want to send some text over wireless. It wasn't really too bandwidth intensive, but then we started seeing people wanting to stream video and put large amounts of data over wireless, and so 802.11n was kind of drafted to address those. So it actually operates on both 2.4 and 5 gigahertz frequencies, but it has speeds of anywhere from 300 to 600 megabits per second, so significantly faster than some of the older standards were. So 802.11n, again, is the newest ratified standard. It's already starting to show its age. It was ratified in October of 2009, and again, it was drafted to address some of the bandwidth issues of the older standards. So People wanted faster speed. People wanted it to work with gigabit Ethernet. The one thing you'll notice in 802.11n and 802.11ac devices is that most of the Ethernet ports are gigabit, because otherwise you would actually have a backlog through the Ethernet port if you only had a 10100 megabit Ethernet port as opposed to gigabit. So how does 802.11n do it? There are basically three main features, if you will, in a nutshell, that 802.11n has that some of the previous technologies did not. The first is it uses what's called MIMO, or multiple in and multiple out technology. And that basically is a technology that uses multiple spatial streams or multiple data streams running at the same time. It basically trunks those on either end, and so what you get is this very high increase in bandwidth. In addition to that, the channel sizes are double what they were in the older standards. So the older standards had 20 megahertz wide pipes, or channels, if you will. 802.11n uses 40 megahertz. You can think of this kind of like a volume of water that flows through a pipe. If you've got a small diameter pipe, you only have a small amount of water that can flow through it. But if all of a sudden you double the size of that pipe, you have a significantly larger volume of water that can then flow through that. So it's very similar with wireless channels. The wider the channel, or the larger the channel, the more data can flow through it. And finally, 802.11n is nice because it's backwards compatible with the older A, B, and G standards. Now there is one thing to keep in mind when it comes to the backwards compatibility. The 802.11n standard is only backwards compatible to the same frequency standards that it's running off of. So if, for example, you're running 2.4 gigahertz N, it will only be backwards compatible with B and G and not with A. And conversely, if you are running 5.5 gigahertz 802.11n, it's only going to be backwards compatible with 802.11a and not B and G. So just kind of something to keep in mind. Now there's a couple main concepts to keep in mind when you're looking at wireless. There's basically two types of topologies that you can look at. One is called an AP client. This is also known as point to multipoint or infrastructure mode, depending on who you talk to. It's kind of used interchangeably, or those are used interchangeably. So in this type of a topology, you basically have one or more main devices. For simplicity's sake, we'll say we have one main AP or access point that's going to serve multiple client devices. So what that means is that all the client devices are getting all of their data and sending all of their data through the one AP. So this is the same type of infrastructure that you would see, say, in your homes or your offices or in a lot of your facilities. Now there's another type of topology which is known as WDS or bridging, and this is typically going to be a point-to-point topology. So there are, a few different ways to do this. Some of them are proprietary, some of them are not. WDS is one of the older standards. It stood for Wireless Distribution Systems, and it's still in use today, but it's a little bit more complicated to set up because you need to know the MAC address of each device that you're communicating to in that bridge link. But this type of topology is very, very useful when you're trying to bridge longer distances or bridge two separate facilities together. So say, for example, you have your control room, and then across, maybe an open field, you've got, I don't know, a water tank that you're trying to monitor with multiple sensors. So you can wire all those up into a device that communicates to a wireless device. That will communicate back to your control center, and you have that dedicated link between the two of them. The nice thing about a bridging type topology is that since it's a dedicated one-to-one link, you don't have any other devices that can basically hop on and disrupt your wireless network, because it's typically set up for only one device, which is the remote end, being able to communicate across it. Now the last thing to keep in mind with wireless, which we don't have to concern ourselves with as much with wired. Of course, you always do need to be concerned about security even with a wired network, but especially true for wireless networks, because wireless tends to be very easy to hack into or to see the data going across it if you don't actually have security. So there's basically three types of securities that are available today. There's WEP, WPA, and WPA2. WEP was kind of the first one that was created. It's a very legacy standard. It's not one that we recommend you use nowadays, because if you have somebody who knows what they're doing, it's easy for them to be able to see the key and break into your network in a matter of seconds. So certainly better than nothing, but if you have available to you either the other WPA options, those are definitely the ones that you want. WPA was kind of created to address the deficiencies in WEP. It's a much better security standard. And then even better than that is WPA2, which is what we recommend you use if you have the option available to you. Now within both WPA and WPA2, there are two types of what we call authentication. And authentication is simply a way of your device proving it is what it says it is. So the first is the most common. It's known as WPA personal. You may also see this as pre-shared key or PSK. Those are all the same thing, but basically it's what most of you will use when you log into your wireless, which is you type in a password. If it matches what the AP has, it'll let you onto the network. The more stringent of the two is known as WPA or WPA2 Enterprise, and this uses a radius server to basically authenticate a device. So every device that needs to get onto that wireless network will then have to have a certificate that basically resides on it. And that certificate is sent through the AP to the backend radius server. It then authenticates it based off of what it has on it, and if it matches, then it'll then tell the access point to basically allow that end device to have access to the network. If not, it'll basically block it out. So that one takes a little bit longer to authenticate, but definitely provides the strongest level of security. All right, so we're going to do a quick wrap-up here, and then we'll have time for some Q&A. I wanted to start off by kind of showing you guys a quick summary table here of all the different options that both Paul and I covered today. So you can see here the different 5 tips that we went over, whether it be using a switch, a PPP link, a fiber converter, a DSL extender, or wireless. And we've kind of picture coded these, if you will, so you can see what is the best for what type of scenario. So switches, for example, are not that great for distance. As Paul mentioned, the limitation of that is around 328 feet. Not so great for isolation, but they are fairly, the media is fairly inexpensive, and the hardware for switches now has come down very dramatically to where it's a very low cost or kind of ubiquitous item. Similarly, with a PPP link, it's the same thing. You have very inexpensive media, very inexpensive hardware. We switch over to fiber converters, which are awesome for distance because fiber again can go upwards of 50 kilometers, and it's great for isolation because most fiber will be isolated. However, fiber tends to be very expensive. DSL extenders, they are very good for distances, not so great for isolation, and the media, because it's already there, is pretty much free, which is awesome. And then, of course, the cost of the hardware is kind of in the middle of all of them. Finally, for wireless, depending on the technology you use, can go anywhere from 1 to 5, sometimes even 10 kilometers, depending on your hardware. So it's got pretty good distances associated with it. A lot of the newer wireless devices are isolated from both an Ethernet, from both a power and a wireless or an antenna or an RF perspective. Of course, there's no cost to the media with wireless because it uses air, and the hardware of wireless devices has come down pretty dramatically over the last 5 or so years. So depending on what it is that you guys need, or you can kind of use this easy chart to see what would be the best option for you. And with that, I'd like to take the last poll questions here, which is, of all of these methods, what have you seen that would be the most useful for you or for your applications? Would it be an Ethernet switch, a PPP link, a fiber converter, a DSL extender, or wireless? And we're going to give you guys just a few minutes here to answer.
All right, we really appreciate your feedback. We'll see which one of these 5 tips is going to come out on top. All right, we'll give it a few more seconds. A little bit surprising maybe, or maybe not. All right. Last chance, and here we go.
All right. Thanks, Oliver. Thanks, everyone. So a little bit surprising, actually, where we have a pretty close split between an Ethernet switch, a fiber converter, and wireless. So looks like none of you are kind of stuck in the old school days with the PPP link. And a few of you look like DSL extenders could be useful, but looks like the highest number was fiber converters. So thank you very much, everybody, for participating in our poll today. All right, so that concludes the presentation portion of our webinar today. We're going to open it up to you guys for any questions you might have that we have not answered during the webinar, and I'm going to turn it over to Oliver.
All right. So I'll go ahead and paraphrase some of these questions. We have some great questions, and we still have time to take more. So if you do have some lingering questions, don't be afraid to use that questions pane right now. For the first question, how far can DSL extenders be used? Do you have a chart running the range of rates and distances for your products, including Cat6 and number 12 power cable?
All right, thanks, Oliver. Great question. Yeah, so again, DSL ranges will depend very heavily on not only what type of DSL technology you use, but also the type of wiring that you use. So SHDSL will go up to about 8 kilometers. VDSL2 will go up to about 3 with a max bandwidth about 1 megabit per second, whereas SHDSL will only go up to about 192, and that's in ideal circumstances. So we do actually have kind of a chart that maps out, you know, distance versus throughput as well as with type of wiring. So that is something that we are certainly happy to help with. If you guys want to ping us for help with your DSL application, we can certainly help you out with that.
Thanks. That was a great question and a great answer, Ariana. I do know that we do have some charts for specific technologies, not a combined chart that compares all the technologies together. So that's a great question, great suggestion, and we'll definitely take a look into that. Next question, do different wireless standards have different communication distances?
All right, I guess I'll take that one as well. Yes, they definitely do. So, you know, we talked predominantly about Wi-Fi today. Wi-Fi's typical range, depending on whether you're looking at more of an enterprise or consumer level wireless or an industrial wireless. Consumer level ones typically will top out at about 30 meters. They're not very powerful radios. Industrial ones can go upwards of about 5 kilometers, sometimes even more if you have really high gain antennas or if you have some sort of a booster, you know, to your radio. But 2.4 gigahertz, if we're talking strictly about Wi-Fi, will go much longer distances than 5 gigahertz will. So if you're looking to do a longer distance across Wi-Fi, you definitely want to take a look at that. If you need to go even farther than that, there is some technology with 900 megahertz, which can go up to anywhere from 30 to 50 kilometers, but you will have significantly lower bandwidth at that distances. So you're talking at most like a meg. So of course there's a give and take depending on, you know, what your bandwidth needs are and what your distance needs are.
All right, thanks very much, Ariana. Moving on to the next question. Keep those questions coming. We're getting some really good questions, and we definitely want to hear your questions so we know how to tailor this content for you and to help you with your application. Do media converters always need 2 fibers? I think that's one for Paul.
Yeah, I think that is one for me here. Yeah, good question, and I kind of alluded to that but didn't explain that totally. The most common type is to utilize 2 individual fibers for the transmit receive as shown on the diagram in the presentation. However, there is another technology called WDM, or wavelength division multiplexing, which is able to share a single fiber between the edge devices and do that by shifting the frequency of the light. So it is possible. It's a little specialized, and you're going to, you know, end up paying more for that. But in the right application, it can be advantageous, you know, when you look at the total installed cost, or if you're in a situation where you've got only 1 fiber left that's already buried or that's in a conduit, and it can be a great way to get that additional functionality.
All right, thanks very much, Paul. Questions are coming in. It's hard to choose which one to get to first. Is it recommended to extend your network over a power line or over power line carrier? I'm not sure who this one should go to.
Maybe I'll jump in on that. That's a very specialized technology. That's a power line carrier has been something that's been used in the consumer space for extending Ethernet, throughout your house. And there have been some efforts for that for the utilities to communicate with homes for some devices. There's some real challenges with that, and I haven't seen that used for industrial applications in a fashion that's commonplace for things that we've talked about today in the scope of plug-and-play types of industrial applications.
All right, great question, and thanks for that answer, Paul. Very useful to know. Here's an interesting question. How do you know if the already installed media is multi-mode or single mode?
And I guess I'll take that one as well. Generally, you can look at that by the cable sheath on the outside. You'll find the specifications printed on there generally. If not, you'll find the manufacturer's part number. If it's not on the jacket, you can simply look it up for the manufacturer and find out. If you're in a situation where that's been, it's dirty and it's not easy to see, there is optical test equipment that will help you determine that. That's not the best way to do it, but if you're in a pinch, you can do that, and you'd probably need to consult a specialist for that.
All right, thanks a lot, Paul. What are your thoughts on the Zigbee wireless standard? This could go to either Ariana and Paul based on their background, so I'll leave it to you to fight it out.
Okay, I'm getting the finger pointed at me here. But yeah, it's an interesting technology as well for that, and there has been some use of that technology. Many of you probably don't know what Zigbee is. It's a low-power wireless network that's typically used in a mesh configuration where you've got problems with signal propagation of having strict line of sight. It's really kind of at this point kind of a niche technology. There are some commercial versions of it out there. I think the areas that I've seen the most prevalent use of it's been within building automation applications. And interestingly enough, most of the building automation suppliers don't refer to it as Zigbee, but actually they're proprietary standards that utilize the 802.15.4 radios and some parts of the Zigbee standards. So I guess in general my response being more of a niche type technology that works well from building automation, but maybe not something that's well applied to general industrial automation applications at this point. I'll turn it back to you, Oliver.
Thanks very much. Great answer and great question. Very interesting question. That does come up every once in a while, questions about Zigbee. Do we have a selection guide for selection of a wireless antenna? And after this, we'll take one more question.
All right, thanks, Oliver. Yeah, we do actually. Moxa has kind of we call it our IW selector guide, and we can send you guys the link after this webinar or when we send out the materials from the webinar today. But basically, it'll allow you to choose your device. It'll allow you to choose what frequency you're using, kind of what distance you're looking at, and then it'll help you select the appropriate antenna as well as accessories. In addition to that, we do have what we call our long-distance calculator, which is actually a really neat little utility, and we'll send you guys the link for this as well to those of you who are interested. But basically, it'll tell you how far your wireless network can go. So you basically put in, what standard you're using, what distance you're looking to go at, what data rate you need to do. It'll kind of generate a chart for you that shows you frequency versus distance. So it's a great little utility to use when planning a wireless network. In particular if you're doing it outdoors, and that is something that we make available, of course, free of charge to anybody. So we can send you guys both of those links, and if neither of those are sufficient for you, give us a call. We're always happy to kind of help walk you through any kind of wireless or other application selection.
All right, thanks very much for the question and thanks for that answer, Ariana. We'll take one more question. Okay, so for the last question, Pat power inputs option available. We mainly have a 48 VDC telco standard available for powering equipment. I know that this is not one that we can probably answer. It does depend on the product, but I'll see if Ariana and Paul can elaborate at all on this.
Yeah, thanks, Oliver. Yeah, I mean, we do actually have a lot of flexible power inputs for a lot of our products. The wireless, I know, will be able to go anywhere from 12 to 48 volt DC, so it's got a pretty variable range. A lot of our switches are powered off of 48 volt DC, particularly the ones that have PoE support built into them. And a lot of our switches will have, options for both, 24 volt, 48 volt DC, or even higher voltage. So 125 volt DC, that type of thing. And Paul can chime in for some of the other products that we have as well. I believe we have some wider ranges for those as well.
Yeah, I think it depends upon the specific product family, but I think the same ranges, Ari, that you kind of covered are available for the majority of the products.
With that, I would like to thank Paul and Ariana for the information that they shared today, and to everyone here for attending.